Since its invention, humanity has consumed over 9 billion cans of Spam. In the West, it's often viewed as a cheap fallback for bare pantries. But in South Korea, it is packaged into elaborate, expensive retail gift sets for the holidays. To understand how a block of pork reached this level of global saturation, we have to look back to the American Great Depression. In the 1930s, long bread lines were common, and meat of any kind was an unattainable luxury for the average struggling family. At the same time, the meatpacking industry had a massive inefficiency. Pork shoulder was incredibly cheap, but it was awkwardly shaped, loaded with connective tissue, and spoiled rapidly. Butchers had almost no use for it. Factory owner J. Hormel saw an opportunity in those exact flaws. He wanted to take those perishable, low-value scraps and process them into a uniform, sliceable block of protein that could sit on a shelf for years. Curious, leaning in. But raw meat naturally rots in a matter of days. To prevent that decay and keep a block of pork edible for 5 years at room temperature, the factory must execute a highly specific sequence of industrial and chemical processes. The engineering required to pull this off operates on a strict 48-hour timeline from the farm to the sealed can, and the chemistry actually begins before the animal is even slaughtered. Notice how stress causes lactic acid to accumulate, plummeting the tissue's pH. If we look at the cellular structure, this acidic pH breaks down muscle fibers. Meat harvested like this turns gray and tough. Controlling the environment ensures the tissue remains stable. Once the meat reaches the factory floor, it is broken down into a precise architectural ratio. Pork shoulder provides the necessary fat and flavor, while ham adds the lean structural integrity required to keep the final block intact when sliced. These cuts are ground and fed into massive industrial vats, but the factory enforces a strict limit, exactly 1,000 pounds per batch. Through trial and error, engineers found this is the maximum possible volume where the blades can achieve a perfectly uniform blend. As those blades spin, friction generates intense heat, which threatens to denature the proteins too early and ruin the texture. To suppress this, workers dump raw ice into the vat, keeping the slurry cold and stable. Next comes the most critical additive in the entire formula. Sodium nitrite is introduced into the organic mass. This compound serves a dual chemical function. First, it absolutely neutralizes the deadly anaerobic bacteria responsible for botulism. Second, it bonds tightly with the myoglobin in the meat, permanently locking in that trademark pink color. By the time the mixture leaves the vat, it is a chemically stabilized, uniform pink slurry. Yet, to achieve true shelf stability, it still has to undergo a brutal physical transformation. The raw slurry is pumped through heavy machinery and rapidly injected into metal cans lined with a food-grade epoxy, filling them at a blinding rate of 300 cans per minute. A machine then extracts all the oxygen from the container, creating an absolute vacuum, before applying what is known as a double seam. If we look at a high magnification cross-section of this double seam, you can see exactly how the metal edges tightly interlock. This mechanical barrier must be executed with micron-level precision, because a single microscopic flaw will allow external microbes to breach the vacuum and destroy the 5-year shelf life. The sealed cans, which still contain entirely raw meat, are then loaded into an industrial autoclave, essentially a massive pressure cooker that exposes them to 150 degrees Celsius. Inside that sealed metal environment, the thermal dynamics are violent. The extreme heat thoroughly cooks the meat and completely annihilates any remaining microbial spores, leaving behind a totally sterile void. This intense pressure also forces collagen and water out of the meat fibers. As the can cools, those extracted proteins pool around the edges, solidifying into that iconic, transparent, protective jelly. The chemical stabilization of nitrite, the absolute vacuum, and the extreme thermal pressure is the engineering that allows a highly perishable piece of meat to survive for years at room temperature. By 1941, the United States military was facing a severe logistical crisis: how to feed millions of troops deployed across oceans. This indestructible meat brick was the perfect solution. Over 1.5 billion pounds of Spam were shipped across the Pacific Theater, delivering vital protein to front lines where refrigeration was completely impossible. American troops ate it so often they eventually grew to resent the repetitive rations. But for the war-torn civilian populations they encountered, this sterile, shelf-stable meat was a vital source of protein in a time of extreme scarcity. That wartime dependency firmly embedded the product into the cultural DNA of places like the Philippines, Hawaii, and South Korea. Over the decades, it evolved from a survival ration into a celebrated culinary staple. Today, a can of Spam represents a landmark achievement in 1930s thermodynamics and biochemistry. It is an edible time capsule that solved a massive logistical hurdle, turning a cheap scrap of pork into a global industrial staple.